Graph the region described by the inequality. The inequality is 7x minus y is less than or equal to 4. Now this is an inequality using two variables, and so we're going to use two dimensions to graph. Now when we graph an inequality like this, there are two parts to it, the boundary and the shading. So we're going to start with the boundary. Now the boundary is going to be a line, and you're going to change the inequality symbol to an equal symbol. You have 7x minus y equals 4. That's our boundary line. Now the boundary line can be included in the region or not included, and it depends on which inequality symbol we use. When we use the inequality symbol less than or greater than, the boundary is not included. And when we use the symbol less than or equal to and greater than or equal to, the boundary is included. And remember, the boundary is using the equal symbol, so it makes sense that whenever we use the equal symbol in our inequality, that the boundary should be included. Now when the boundary is included, we use a solid line to indicate that it's included. When it's not included, we use a dashed line to indicate it's not included. So because we have a less than or equal to, our boundary will be included, and we are going to graph our line as a solid line. So then we want to graph our line. There are many ways to graph a line, and one of them is to use slope-intercept form. So I'm going to take my equation 7x minus y equals 4, and let's rewrite it in slope-intercept form. So I subtract 7x. It's negative y is equal to negative 7x plus 4. Divide by negative 1. And we get y equals 7x minus 4. This is an equation in slope-intercept form. The y-intercept is negative 4, and the slope is 7, and we write that as 7 over 1. So we can graph this line by plotting that y-intercept of negative 4 using the slope to get to a second point. So we're going to rise 7 and run 1. So now we have 2 points on the line, and we'll connect those 2 points with a solid line because that boundary is included. So that's the first part, the boundary line. Then we want to do the shading. So this boundary line divides the region up into two sections, or two separate regions. We have this region here and this region here. We need to decide which one of those regions we're going to shade. We want to shade the side that makes it true. So we're going to shade the true side, and the way we figure out which side is the true side is with a test point. So for the shading, you're going to choose a test point, and there's only one rule with the test point, and that is that the test point cannot be on the line. Now, most people like to choose 0, 0 as the test point, and that's allowed as long as 0, 0 is not on the line. So in this example, we can use 0, 0 as our test point. And you're going to substitute the test point into the original inequality. That would give 7 times 0 minus 0 is less than or equal to 4. 7 times 0 is 0, minus 0. 0 minus 0 is 0. And we get 0 is less than or equal to 4. That's a true statement. So what we found is that this test point came out true, and that means this whole side is true. So we want to shade that side. If it had come out false, we would shade the other side of the line, because the other side would be the true side. So here we have the region that's described by this inequality. Every ordered pair in this shaded region and on the boundary line is going to make this inequality true. Graph the inequality 5x plus 2y is greater than 10. When we graph an inequality like this, there's really two parts to it. The first part is going to be the boundary line, and the second part is the shading. So let's start with the boundary. The boundary line will change the inequality to an equal. 5x plus 2y equals 10. When we graph the boundary line will either be included or not included, and we use that inequality symbol to decide whether it will be included or not. So because we have a greater than, that boundary line is not included, and we're going to draw the line as a dashed line. So there are many ways to draw that dashed line. This time I will draw the line using x and y intercepts. We need to find 2 points on the line. I'll find the x-intercept by letting y equal 0. That's 5x plus 2 times 0 equals 10. 5x equals 10. Divide by 5 and we get x is equal to 2. So we know that the ordered pair 2, 0 is on the line. Then we'll find the y-intercept by letting x equal 0. That's 5 times 0 plus 2y equals 10. 2y equals 10, divide by 2, and y equals 5. So we have a y-intercept of 5, a second point on that line. We just need to connect those 2 points with a straight line, and remember it should be dashed because our inequality is a greater than. So once we've drawn the line, then we're going to figure out the shading. To do the shading, we need to pick a test point. And there's only one rule with the test point. It can't be on the line. So most people like to choose 0, 0 as the test point. And 0, 0 is not on our boundary line, so we can use it. We're going to plug that test point into our original inequality. That would give us 5 times 0 plus 2 times 0 is greater than 10. 5 times 0 is 0, 2 times 0 is 0, 0 plus 0 is 0. 0 is greater than 10 is false. So this time our test point came out false, and that means the other side is true. So we're going to shade on the other side. We always want to shade on that true side. For this example, the points that are shaded all the way up to the boundary, but not including the boundary, are the solutions to this inequality. Graph the system of inequalities. X plus 2y is less than or equal to 2. Y is greater than or equal to x squared minus 2. So let's start with the first inequality. The first inequality is x plus 2y is less than or equal to 2. We're going to graph the boundary, x plus 2y equals 2. And we're going to graph that boundary as solid because we have the equal to in our inequality. We can graph this using slope-intercept form. So I'm going to solve for y. So subtract x. That's 2y equals negative x plus 2. Divide by 2. And y equals negative 1/2 x plus 1. And we have a slope of negative 1/2 and a y-intercept of 1. So we can graph this line by plotting the y-intercept of 1. And with our slope is negative 1/2, so we're going to do rise over run. The rise is negative, so we're going to go down and run 2, so go right 2. And then we're going to connect those 2 points with a solid line. Okay, so we figured out the boundary. Now we're going to figure out the shading. I need to choose a test point. So I'll choose 0, 0 as my test point. And we're going to substitute that into the inequality, the original inequality. That's this one here. X plus 2y is less than or equal to 2. So 0 plus 2 times 0 is less than or equal to 2. When you simplify, you get 0 is less than or equal to 2, and that is true. So we're going to shade on the same side with that test point. So we've graphed that first inequality. Okay, so let's go ahead and continue with that second inequality. It's y is greater than or equal to x squared minus 2. We want to start by graphing the boundary. And the boundary would be y equals x squared minus 2. And we've got an equal to in our inequality, so we're going to graph this line as a solid line as well. Now this equation is not a linear equation, it's a quadratic equation. So we can't just use 2 points to graph the line. We may be able to, I believe we have to use 3 points. So let's say we use negative 1, 0, and 1. We substitute that into our equation, and that would give negative 1 squared minus 2. That's 1 minus 2 equals negative 1. 0 squared minus 2, that's negative 2. 1 squared minus 2, that's 1 minus 2, which is negative 1. So that gives us three ordered pairs, -1, -1, 0, -2, and 1, -1. So let me erase this test point here because it's in the way. And we're going to plot -1, -1, 0, -2, and 1, -1. And we're going to draw that with a solid line as well. And I'm just going to put that shading back that I erased a second ago. And now we need to find the shading for the second line. Once again, we need a test point. And the only rule is that you have a test point that's not on the line. So we can use 0, 0 again, since 0, 0 is not on the line. We're going to substitute that into the original inequality. 0 is greater than or equal to 0 squared minus 2. That simplifies to be 0 is greater than or equal to -2, and that's true. So I'm going to switch my color here for shading. So we have the true side being inside the bowl of the parabola. And the final thing that we need to do here is to see what's in common. We graphed the first inequality, that's the line with the orange shading. We graphed the second inequality, that's the parabola with the yellow shading. And when you're looking for a system, you're looking for points that are in common with both inequalities. So the ones that are in common are going to be the ones that are shaded in both yellow and orange. So that's the ones inside this region right here. And I'm also going to include those solid boundary lines as well. So if you're doing this in my math lab, which a lot of you will be doing, you would graph the line, graph the parabola, and then use your paint bucket to fill this region here, inside, in between the line and the parabola. Solve the exponential equation. 3 times 5 minus 11 to the 4x minus 3 equals 5. So we can see from the directions that this is an exponential equation, but we can also see, because our variable is in the exponent, that we have an exponential equation. Now, when we have exponential equations, we have three methods that we typically use to solve them. We try to make the basis the same, so we try to get it to a state like this, where we have the same base on both sides raised to a power. We're not going to be able to do that in this example. We have a base of 11 on our exponential, and it doesn't look like from the other numbers we're going to be able to get a base of 11. The other method involves having something like e to the x equals y, and from here you would take the log of both sides, or you can convert it to a log. We can use either of those methods, but in order to use those methods, we have to have our exponential isolated on one side of the equation. So here is where our exponent is attached to this base of 11. We want to have that exponential isolated on one side of the equation. So we've got to get rid of that 3. So I would divide by 3 on both sides. That would give 5 minus 11 to the 4x minus 3 equals 5/3. Then I'm still trying to isolate, so I would subtract 5 on both sides. That's negative 11 to the 4x minus 3. And we want to combine this fraction and whole number together. So in order to do that, we need to have a common denominator. So I'm going to rewrite that 5 as 5 over 1. And the common denominator will be 3, so I'll multiply the second one by 3 over 3. And that gives negative 15 over 3. So now I can combine these together. 5 over 3 minus 15 over 3 will give me a negative 10 over 3. Okay, one more step and I'll have that exponential isolated. Let's divide by negative 1 on both sides. And we have 11 to the 4x minus 3 equals a positive 10/3. And once we get that exponential isolated, we're going to use one of our methods for solving exponential equations. You can take the log of both sides or convert it to a log. I prefer to do the natural log of both sides since it's easier to input the answer in the calculator. I'll do natural log on the left, natural log on the right. That gives the equation natural log of 11 to the 4x minus 3 equals natural log of 10/3. Once we introduce the log, we can use the power rule for logarithms and move this exponent to the coefficient. That gives us 4x minus 3 natural log of 11 equals natural log of 10/3. And then we'll do the distributive property on the left, giving us 4x natural log of 11 minus 3 natural log of 11 equals natural log of 10/3. Now that I've gotten rid of the parentheses, my goal is to solve for x. I'm going to add 3 natural log of 11 on both sides. That leaves us with 4x natural log of 11 equals natural log of 10/3 plus 3 natural log of 11. Now we'll isolate that x by dividing both sides by the 4 and natural log of 11. And we have our solution, x equals natural log of 10/3 plus 3 natural log of 11 over 4 natural log of 11. We'll take a look at our work and then put this in the calculator to get an approximate answer. I'm going to go to the calculator's home screen. Let me clear this out so that you can see the buttons I'm typing here. Now when we type this, we do need parentheses around the numerator. I'm going to have parentheses, natural log 10 over 3. And you'll notice that when I type natural log, the calculator automatically put a parenthesis at the front of that. So I've got to close that parenthesis. And then I need to do plus, plus 3 natural log 11, close parenthesis for that log, and close parenthesis for the whole numerator. And I'm going to do division, and I also need parentheses around this denominator. I've got more than one thing in the denominator, so I need parentheses for natural log 11, close parenthesis for the log, and close parenthesis for the whole denominator. And so we get, for this one, 0.8755. So let me zoom out so you can see that whole problem. So let's just recall what we did to solve this problem. It's an exponential equation, and I need the exponential isolated. So I started off by isolating this 11 to the 4x minus 3. We did that by dividing by 3 on both sides, subtracting 5 on both sides, and dividing by -1 on both sides. Then once we isolated that exponential, we took the natural log of both sides. That allowed us to get the variable out of the exponent. We used a distributive property, and then we were getting x by itself. So we subtracted the 3 natural log of 11 and divided by 4 natural log of 11. Let's see that calculator one more time. So we ended up with 0.8755. Graph the inequality -x plus 3y is less than -12. When we graph an inequality with two variables, we want to graph a line with some shading. So we're going to start by graphing the boundary. And in this example, we're going to graph the boundary as a dashed line because we have a less than inequality. That means the boundary is not included. That boundary is going to be -x plus 3y equals -12. So we just changed that inequality symbol to an equal symbol. Now, we've learned in this class multiple ways to graph straight lines. We've learned to plot points, we've learned to use slope-intercept form, and we've learned how to use the intercepts to graph a line. In this example, I'll use the intercepts to get a little variety of practice. So let's start off by finding the x-intercept. We'll find the x-intercept by letting y equal 0. That will get -x plus 3 times 0 equals -12. That simplifies to be -x equals -12. We'll divide by -1 on both sides to get x equals 12. So we have an x-intercept of 12. We'll go ahead and plot that x-intercept. Then we'll find the y-intercept by letting x equal 0. That gives the equation -0 plus 3y equals -12. That's 3y equals -12. Divide by 3, and y is equal to -4. So we have a y-intercept of -4. I'll plot that y-intercept, -4, and we want to connect those 2 points with a dashed line because our boundary is not included. Once we get the boundary drawn, then we're going to do the shading. When we do the shading, we want to pick a test point. And with that test point, we need to make sure that we pick an ordered pair that is not on the line. Most people like to choose 0, 0 because the math works out very easily when you have 0, 0. So we'll choose a test point of 0, 0, and we substitute that into the original inequality. That will give -0 plus 3 times 0 is less than -12. And when we simplify, we get 0 is less than -12, which is a false statement. 0 is not less than -12. So on the side of our test point, we got false. The other side is true. We always want to shade the true side, so we're going to shade the other side of the line. Now these ordered pairs that we're shading are all of the ordered pairs that make the inequality true. So this picture represents all of the ordered pairs that make that inequality true. Graph the system of linear inequalities in two variables. We have x plus y is greater than or equal to 2, and 2x minus y is less than or equal to 3. So when we graph a system of linear inequalities like this, we want to graph the two inequalities individually and see where they overlap. So let's start with the first inequality, x plus y is greater than or equal to 2. We're going to start by drawing the boundary. The boundary is going to be x plus y equals 2. So we've just replaced that inequality symbol with an equal symbol. And when we graph this boundary line, we're either going to draw it as solid or dashed. If we pay attention to the inequality symbol, it will tell us whether we draw it solid or dashed. When we have that equal to, we draw it solid. When we don't have the equal to, we draw it dashed. Solid means it's included, dashed means it's not. So we're going to draw this boundary line using slope-intercept form. So let's solve for y. I'll subtract x on both sides. We get y equals negative x plus 2. So this line has a y-intercept of 2 with a slope of negative 1. So let's plot that y-intercept of 2. If it has a slope of negative 1, we'll go down 1 and over 1. Down 1 and to the right 1, and we're going to connect these points with a solid line. Once we've done the boundary, then we're going to do the shading. We want to pick a test point. The only rule with the test point is that it can't be on the line, so we're going to pick 0, 0 as our test point. And we're going to substitute that into our original inequality. So when we do that, we would have 0 plus 0 is greater than or equal to 2. 0 is greater than or equal to 2 is a false statement. So when it's a false statement, you shade on the other side of the line, the side that doesn't contain the test point. Okay, now we're done with the first inequality. Let's do the second one. The second one is 2x minus y is less than or equal to 3. We're going to graph the boundary. That's 2x minus y equals 3, and we're going to draw it solid because we have the equal to in our inequality. I'm going to write this line in slope-intercept form. So let's subtract 2x. We have negative y equals negative 2x plus 3. Divide by negative 1. And we have y equals 2x minus 3. So this line has a y-intercept of negative 3 with a slope of 2, or 2 over 1. We have a y-intercept at negative 3. We'll use rise 2, run 1 to get to a second point, and we'll connect those 2 points with a solid line. And now we need to figure out the shading. We're going to pick a test point. We can pick 0, 0 again and substitute it into our original inequality. So when we do that, we would have 2 times 0 minus 0 is less than or equal to 3. That's 0 is less than or equal to 3. And that is a true statement. When we have a true statement, we're going to shade on the same side of the line. So I'm going to pick a different color so that we can see the overlap. And I'm shading on the side of the line that contains the test point. You see how I shaded over the test point this time. Now, when you have a system of any kind, we're going to be looking for the points that are in common with both of them. So that's why we look at this overlap here. So the solution for our system will be the points that are in just this region here where the two shadings overlap, and you would include those boundary points as well because they're solid. If you're doing this in my math lab, you are going to draw both boundary lines, figure out which region you're going to shade, and then use your paint bucket only on that region. In my math lab, it's hard to delete the paint bucket, so save the paint bucket for the last part and fill in only that region where they overlap. Benjamin Associates, a real estate developer, recently built 190 condominiums in McCall, Idaho. The condos were either 2-bedroom units or 3-bedroom units. If the total number of bedrooms in the entire complex is 486, how many 2-bedroom units are there and how many 3-bedroom units are there? So this is an example where we can use a system of linear equations to solve. We're going to let the number of 2-bedroom units, so we've got the question, how many 2-bedroom units are there? We'll let that be our variable x. How many 3-bedroom units are there? We'll let that be our y. So Benjamin and Associates built 190 condominiums. So we can get our first equation by saying that the number of 2-bedroom condominiums plus the number of 3-bedroom condominiums has to equal the total number of condominiums, 190. Now then the second equation is going to come from this information here, the number of bedrooms. So let's think about this for a second. If you knew that they built 10 2-bedroom condos, and you needed to know how many bedrooms there were, you could multiply 10 condos times 2 bedrooms each would be 20 bedrooms among those 10 condominiums. We're going to do something similar. We have X number of 2-bedroom condos, so that means 2 times X bedrooms. We have Y number of 3-bedroom condos, so 3 bedrooms times Y number of condominiums. That means we have that many bedrooms. And that should add up to a total number of 486 bedrooms in the complex. So we now have 2 equations with 2 unknowns, and we can solve this with either substitution or elimination. I'm going to try substitution on this example. We're going to take that first equation, x plus y equals 190, and let's solve for x, so I'll subtract y. I get x equals 190 minus y. And we're going to substitute that into the other equation. So let's substitute it in for x. And that's going to give us 2 times 190 minus y plus 3y equals 486. I use the distributive property. 190 times 2 is 380 minus 2y plus 3y equals 486. Let's combine those y's together. We have 380 plus y equals 486. I'm going to subtract 380, and that gives y equals 106. And we can substitute that 106 back in here to figure out what x is. X is 190 minus 106, and we get 84. So we now know that we have 106 3-bedroom condos and 84 2-bedroom condos. Thank you for checking out my videos. Have a great day.